This week, I'm going to take a look at these three questions. Why is the quadratic formula useful in the real world? An integral of 4 minus x squared dx, and simplifying this expression here. So if you have a question, you can email it to the email address in the description. You can join the Discord, throw some questions in there. You could leave a comment, and I will try to answer your questions as quickly as possible. But these are some questions that came in recently. So let's get started with the first question. Why is the quadratic formula useful in the real world? So I used to get this type of question a lot more when I taught 8th grade, mostly because it was let's try to stump the teacher, let's try to get one over on the teacher, like, oh, he's not going to be able to answer this question. And at times it's a valid question. I'm not opposed to that type of question. It's good to think about, like, how am I going to use this concept in the real world? Math is just the easiest subject to challenge. It's a really easy topic to say, why do I need this? Why do I care about this? It doesn't really happen a whole lot with other subjects, at least from what I've seen. I think the question of why am I using this in the real world comes up at a way higher rate in a math class than it would in, let's say, like a social studies class. Like, I don't think a lot of social studies students or history students are asking the question, why do I need to know the date of the Industrial Revolution? Like, why is this useful information? I don't think that question comes up a whole lot. Only because math is a lot easier to sit here and say, why do I need to know how to solve the quadratic formula? Like, why do I need to know how to solve equations? Why do I need to know how exponential growth? Like, why is that important to my everyday life? Which at times is valid. So whenever that question comes up, like I said, this question comes up a lot more when I taught 8th grade. But since I started teaching college, it doesn't come up as much. I don't know why. I think probably the reason is college students just see it as like, well, in order to get my degree, I need this class. In order to pass this class, I need to know this concept. So I'm not even going to ask the question, why do I need to know it? Because the college is telling me I need to know it, so I got to learn it. I think that might be the thought process, at least for college students, where 8th graders, they think a little bit more of like their everyday, like right now, why am I learning this right now in this moment? And why am I not doing something else that's way more fun than sitting here in this math class? So I think that's a lot of that thought process. But whenever that question gets asked, like, why am I using this concept? I'll have an answer, hopefully, for like, here's why you would need to know how to multiply fractions. Like, why is this important? Why would this come up in your everyday life? What I also like to say is it's not about the concept most of the time. It's not about the application to the quadratic formula. It's about the process. It's about the problem solving. It's about having that ability to understand a problem, take the correct formula, apply it correctly, and get the correct answer. That's a very complicated process to go from start to finish with no errors. So when you complete a class, a math class, let's say you're in a college algebra class or a pre-calc class, and you pass it, that's telling the next level, like, hey, I'm ready for this next class because I have demonstrated the skills that are necessary for this class. And then you extend that beyond just passing a class, passing the next class, and getting a degree. That degree then tells employers or future colleges, if you're going into like a master's program or a doctoral program, like, hey, I have the skills for this job. So if you get a math degree, you're telling employers, like, I have analytical skills. I have the ability to problem solve. I have a strong ability to look through data and understand it and make patterns out of it and come to conclusions about it and just get a better understanding than someone with, let's say like a theater degree. Like if I'm competing with someone for some sort of data mining job and I have a math degree and that person has a theater degree or an English degree or whatever, ultrasound degree, like, I don't know, whatever other job, the person with the math background is probably going to get that job. And I'm not saying that those people are going to be competing for this class for that job, but I'm just using that as an example of like, that's what this degree is saying, that you have these skills, you have those abilities. So being able to apply the quadratic formula is just one piece of that part that's going to make up what you are as a person with that degree. Now, like an English degree, they probably have a way better ability to read a lot of information and understand all that information after reading documents, legal documents, or being able to summarize or understand that kind of information or write professional documents. Like, that's what their strengths are. And that's what a person with an English degree is saying to employers, like, hey, I can read these documents and I can write these complicated documents very well. So that's why I should do this job. So that's the component of just the degree. And what makes up that degree is these concepts. Being able to understand this concept, being able to pass a class, being able to pass a series of classes that then demonstrates that, hey, I do have the ability to problem solve and do all that kind of stuff. But getting far away from the actual question here presented here, this was on a video. I posted a video. I think it was just a quadratic formula video. This is a while back, and there was some discussion on the video about the quadratic formula, and a viewer asked the question, why is this useful? A lot of people replied like with honest, like very good responses of like, well, in this scenario, the quadratic formula is used. So I just wanted to quickly just talk about like, why is it useful? Like, where is this application kind of come up? For example, if you were standing on top of a building or standing on top of a hill or a rock face or something, and you threw something off, that trajectory of the object being thrown would form a parabola, and that parabola can be formed, like you can write the trajectory of that parabola in a quadratic. So like negative 16t squared plus, and then the velocity of, let's say we throw it whatever, 100t, I'm just kind of making up something, plus a height of 150, whatever it is. This function here, f of t, will relate to that trajectory. And you can gather information from there of what the path would be. Like if I wanted to know, well, how far did it go after 2 seconds, or how long did it take to, what is the time it took to get to 0 feet? So I'd have to solve for t, how long did it take for it to hit the ground is basically the question here. When we hit the ground, so that would be a height of 0. So height of 0, and then you would set this equal to 0, and then you'd have to factor, and that's where the quadratic formula comes into. I doubt that this is a factorable trinomial that I just made up, but maybe it is. Maybe you can factor it, but if you can't factor it, you'd use the quadratic formula. Quadratic formula is used to factor any sort of quadratic, and you would get an answer. You might get like something like t equals 2.3, something like that, where you'd say like, all right, 2.3 seconds it took to hit the ground. That's just one small application of the quadratic formula. Like, are you ever going to be in the situation where you throw a football and it forms that parabola, and you're going to need to figure out, well, how far did it go after t equals 1 second? Like, no, like it's probably not going to happen. There is science behind that, though. There are people who study the trajectory of footballs and how fast and how far it goes based on the release speed and the speed that it's going. There's actually a cool video on Tom Brady about his throws and the speed and the trajectory and how that's calculated and everything. It's actually very mathematically based. It's really cool. But that's just one small application of the quadratic formula. That it's a lot of it could be used as just unfactorable trinomials where you would need to get an answer, so the quadratic formula comes into play. I was trying to keep that relatively short. I mean, I could go on for a very long time about the quadratic formula, and if you study the quadratic formula, you'll see many, many uses for it. But at the end of the day, it's just a formula used to factor unfactorable trinomials, or get some sort of factors there where you can get answers to those complicated questions. And just the trajectory path is one common question. This is actually a really common scenario with throwing a ball or something, or jumping off a cliff or whatever it is. That path forms a parabola, so you can put that into quadratic. Okay, first math question for today is the integral of 4 minus x squared dx from 1 to 2. So I'm going to, this question was asked on a video similar to this. Like, I can't remember what the exact question was, like my video that I posted, and someone's like, I am having trouble with this integral. So here it is. So what I would do for this type of integral is I would just integrate each individual term. So I would get 4x minus, and then integrating this is x to the third over 3. And remember, if we're integrating a constant, this is technically 4x to the 0. So when I integrate that, that's going to become x to the 0 plus 1 over 0 plus 1. So that's why we just get 4x to the first over 1, which is just 4x. So that's why I'm getting 4x there. Then for x to the second, I'm integrating x to the second. that would be x to the 2 plus 1 over 2 plus 1. So you get x to the third over 3. We're just adding 1 to that exponent and dividing by that number. And then we are going from 1 to 2 here. So we have to have those bounds, 1 to 2. When we have a definite integral like this, we want to plug in our endpoint. So it's going to be 4 times 2 minus 2 to the third over 3. And then we want to subtract off the second substitution here. So that's going to be 4 times 1 minus 1 to the third over 3. Eight minus 2 to the third is 8 over 3, minus 4 times 1 is 4, minus 1 to the third is 1 over 3. Guess I'll just do this by brute force. So this is going to be over 3. That's 24, right? 3 times 8, so 24 minus 8 is 16 over 3 minus, and then this is going to become 3, and that's going to become 12. So 12 minus 1 is 11 over 3. Same denominator, so 16 minus 11 is 5 over 3. 5 over 3. 3, 8, 24, 24 minus 8, 16. Just make sure I didn't make any silly errors here. I'm not seeing anything, but hopefully I'm kind of recording this late at night, so I hope that's right. That's just fraction work. Yeah, so integrating this definite integral, just integrate each individual term, and then run it from 1 to 2, plug in 2, plug in 1, substitute that, or subtract that out. Good problem, good problem. Hope that answers that question. Next one, simplifying this. I actually got this from a current student in my class right now. They emailed me this question. Not sure how to do it. I sent back a reply through email, but I wanted to at least record a video along with that reply just in case they wanted to see it worked out. Because I know it's kind of hard to grasp it completely with email response. But this problem's kind of cool because they want us to simplify, and at face value, it's like, what am I doing here? I don't have any like terms I can combine. You know, what can I possibly do? And there might be some multiple methods here that we can take. But what I'm noticing right away is that I have 4 terms on top and bottom. So I'm probably going to jump to group factor by grouping. And right now, with the way it's set up, I'm noticing 2 things. I'm noticing that like if I group these 2 and then group these 2, I could take out x here, and then I think we might be okay. Because sometimes with the factor by grouping, you might have to rearrange the terms. So you have to play around with it a little bit in some cases, but I think we might be fine with just factor by grouping the way it is. So let's see. So I'm going to group these first 2. I'm going to group the second 2, and since I have a minus sign here, that second set will start with a minus sign. Like I can't just do this, because that minus sign needs to be included in this whole entire expression because I want to like plus that middle term. So what I would do is I would change this subtraction to addition and then make that 4 negative. So it's the same thing, but I'm just changing the visual so I can just group that second 2. And then I'll group the bottom and do the same thing. I'm going to put this as plus and then change that to negative. So let's check it out. From the top, I could factor out an x, and then I'm going to be left with 4y plus 5, because when I factor out the x from that one, what I'm doing is I'm dividing everything by x there, so that's going to be x times 4y plus x cancel 4y plus 5. Second set of parentheses, negative 4y minus 5. I don't have anything to factor out. Like I can't factor out a 4, can't factor out a y, can't factor out a 5, there's nothing. So I have to factor out something, but I also have this leading negative here. So whenever I have a leading negative, I want to factor that out. So I'm going to take out a negative 1. I'm going to take out negative 1. So that's going to flip my signs. That negative 4y is going to change to a positive 4y. Negative 5 is going to become positive 5. And look at that. 4y plus 5, 4y plus 5. That's why we do factor by grouping, because we want the same thing inside those parentheses. So now I'm going to factor out the 4y plus 5 as here. Let me go down here. So I'm going to factor out the 4y plus 5. And I'm left with x minus 1. Only thing we could hope for here is that something on the bottom is going to factor with that. So let's check this. So on the bottom, I could take out 3xy plus 8x. I could take out an x. So I'll be left with 3x y plus 8x. So I factor out an x, so I'm dividing both terms by x. So it's going to be x times 3y plus 8. Well, let me go actually right here. Let me just do this right here. So x times 3y plus 8. Second set of parentheses, same thing. I can't take out anything other than a negative 1. So let's factor out that negative 1. That's going to leave me with a positive 3y plus 8. And then 3y plus 8. So I'm going to take out 3y plus 8. And I'm left with x minus 1. And luckily that worked out. Or not really luckily, but just worked out. So I have an x minus 1 on top and bottom. So boom, game over on that one. Those are gone. 4y plus 5 and 3y plus 8 do not simplify. So I'm going to leave it as 4y plus 5 over 3y plus 8. And then that one is now simplified. So the key here is factor by grouping. And the second key to this one is this middle portion. It's right there, that because it's minus. So you want to make sure you're grouping the negative with it. Another way to think about that one, which some people disagree with this, but I have seen this done before. When you group like this, or group and then group like that, where you're just putting that minus sign inside the parentheses. The problem with this is some people disagree with this because now it looks like you've made it a multiplication question, like 4xy plus 5x times negative 4y minus 5. Where here, when I just rewrote it as plus minus, I'm not making it a multiplication question. I'm just rewriting it as this group plus this. I don't really care. Like if my students did it like this, where they just put it like this, like I'm not going to make a big deal about it because I know what they're trying to do. They're trying to factor by grouping, so it's kind of more just like you know what you're doing, you know what you're trying to accomplish with that. But yeah, a lot of people will just prefer that, like just plus minus, which I've actually kind of started to adopt that method in class. I think that's a little bit easier for students to grasp. So, all right, 4y plus 5 over 3y plus 8. So hopefully this helped you out.